Hello everyone. In this video we're going to be looking at how you can solve this question. It is a Cambridge entrance test question and it says we should find the real non-zero solution to the equation 2 to the power of 9 to the power of x over 8 to the power of 3 to the power of x, all equal to 1 over 4. Now let's quickly solve the question. The first thing I'm going to be doing is I have a base of 2 as the numerator and I have a base of 8 as the denominator. You can see that there is a relationship between 2 and 8. It means I can write 8 as 2 to the power of 3. And that's what we are going to be doing now. So we are going to be having 2 to the power of 9, then to the power of x, as in this case, then over 2 to the power of 3, then multiply by 3 to the power of x, as in this case, everything equal to 1 over 4. And from here, we are going to be having 2 to the power of 9 to the power of x over 2 to the power of 3, then multiplying 3 to the power of x, as in this case, everything would give me 1 over 4. And please don't forget another law of indices that says when we have a to the power of b and over a raised to the power of c, that is when we are having the same base and there is division, we just need to subtract the power. So, and in this case, we have 2 as a base, and at the same time, we have 2 as a base for the denominator. So, we are going to be applying this rule. Now, let's quickly put that into consideration. So, we have 2 to the power of 9 to the power of x, then minus 3 multiplying 3 to the power of x, everything equal to 1 over 4. And as you can see, on the left hand side we have a base of 2, which is this, and on the right hand side we have a base of 4. There is a relationship between the both of them. That is, 1 over 4 can be written as 1 over 2 to the power of 2. Now let's quickly do that. Instead of having 1 over 4, let's write 1 over 2 to the power of 2. And at the same time, there is still a relationship. How that I can write 1 over 2 to the power of 2 as 2 to the power of minus 2. Because one of the rules of indices says we have a raised to the power of a negative number, it becomes 1 over then a raised to the power 1. So it means if I have a raised to the power of minus 2, the final answer is going to be 1 over a raised to the power of 2. And that is what I'm going to be doing here also. So 1 over 2 to the power of 2 can be written as 2 to the power of negative 2. So I'm going to be writing 2 to the power of 9 to the power of x minus 3 multiplying 3 to the power of x is going to be the same thing as 2 to the power of negative 2. And don't forget that when we have equal base, all we need to do is we just equate the power. And as you can see, we have equal bases here, 2 and 2. The bases are equal. So since the bases are equal, it means we should have equal power also. The power 9 to the power of x minus 3 multiplying 3 to the power of x must be equal to minus 2. Why? Because the base are the same. So let's quickly do that. So we have 9 to the power of x minus 3 multiplying 3 to the power of x equal to minus 2. And of course, I can write 9 as 3 to the power of 2. 9 can be written as 3 to the power of 2. So let's quickly put that into consideration. So we have 3 to the power of 2, then to the power of x, minus 3 times 3 to the power of x, everything equal to minus 2. And as you can see, I can equally change the power of 2 as we are having here, and the power of x as we are having here. I can interchange them. So which is going to become 3 to the power of x, then to the power of 2. Then we have minus 3 multiplying 3 to the power of x equal to minus 2. Then what I need to do now is bring minus 2 to the left hand side. That is, I'm going to be adding 2 to the both sides, plus 2, then plus 2. So I will be having, when I add plus 2 to the both sides, so I am going to be having 3 to the power of x to the power of 2 minus 3 times 3 to the power of x plus 2 equal to 0. And this I can use substitution, because 3 to the power of x and 3 to the power of x to the power of 2 have a relationship. The power here and the power here, there is a relationship between them. So the power of this is double the power of this. And anytime we have situation like this, we can substitute. So substituting, let's say 3 to the power of x equal to u. So u equal to 3 to the power of x, which means 3 to the power of x to the power of 2 would be u raised to the power of 2. Now let me write it again. If 3 to the power of x equal to u, then it means 3 to the power of x to the power of 2 will be u raised to the power of 2. And let us substitute this into what we have in the equation. It becomes u squared minus 3, then multiplying 3 to the power of x, which is u, plus 2 equal to 0. And this is a quadratic equation. So we can easily simplify this quadratic equation by having two factors of the number here, which is 2, which when we add them together is going to give us negative 3. And that's what we are going to be looking at. What are the factors of 2 such that when we add them together, we are going to be getting negative 3. Now the factors of 2 are 1 and 2. Now if I have plus 1 multiplying plus 2, definitely we are going to be having 2, which is correct with the product. But if I had plus 1, then plus 2 together, am I going to be getting minus 3? No. The answer here is going to be plus 3, which is not the same thing as what we have here. So I need minus 3. So what I'm going to do is I'm going to be using negative 1 multiplying negative 2 to give me positive 2. And at the same time, negative 1 plus negative 2 would give me negative 3. And this satisfies what I have here. So I'm going to be writing u squared minus negative minus u minus 2u then plus 2 equal to 0. Then I can group the both of them, 2, 2. So I'll be having u in the bracket, then u minus 1, and also 2 is common here. Then I will have minus 2, then open the bracket, then minus 2 in minus 2u, we have u. Then minus 2 in plus 2 is going to give you minus 1 equal to 0. So we have 2 factors like this, which is u minus 1. At the same time, we have u minus 2 equal to 0. So all we need to do from here is we have u minus 1 equal to 0, and at the same time we have u minus 2 equal to 0. So from here we have u equal to 1, and at the same time we have u equal to 2. So these are the 2 solutions. But don't forget that we've already substituted the value of 3 to the power of x as u. 3 to the power of x as u. Then we're going to be writing it back. So we are going to be having u, which is 3 to the power of x. Let me quickly. So u is 3 to the power of x. So I'll be having 3 to the power of x equal to 1. And when 3 to the power of x equal to 1, I will raise both to logarithm of base 3. So I'll be having logarithm of base 3 and 3 to the power of x equal to logarithm of base 3 then 1. And of course, we know that I can bring x and have something like this, x then logarithm of base 3 then 3, which is equal to logarithm of base 3 then we have 1. And of course we know that logarithm of base 3 is going to give us 1, and also logarithm of base 3 to 1 is going to give us 0. Therefore x equal to 0, which is one of the solutions. But of course, from the question, we are told that we should find the real non-zero solution. It means, though we've gotten 0 as one of the solutions, but we are not asked to get 0 as our solution. So this 0 that we have gotten is not our answer yet. So we need to find the other solution. Now let's quickly look into how we can get the other solution. So in this case, we have u to be equal to 2. So that means 3 to the power of x equal to 2. Then we can raise both to the logarithm of base 3. So we have logarithm base 3, then we have 3 to the power of x is equal to logarithm base 3, then we have 2. Of course, log of base 3 then to 3. So I'm going to be bringing x. We have x log base 3 then 3 equal to log base 3 then we have 2 here. And of course, log of base 3 and 3 is going to give me 1. So we have x equal to log base 3, then we have 2. So this is the other solution. Now let's check if we have log of base 3 and 2. So we have log of base 3 and 2. So this is our answer. And this is how you go about it. Do not forget to comment, share, and like. You are great.